Okay, cool. So the question is saying, suppose the displacement of an object is related to time according to the expression x is equal to b t squared. What are the dimension of b? Okay, so what are we supposed to do here? To be more like a group discussion, since we did these things yesterday. So what are we supposed to do? They are saying, uh, what are the dimensions of b? So we identify the dimensions of x, which is the displacement, right? So what are the dimension of displacement, or the units for displacement? Meters. And then what are the units for time? But since it is t squared, what is going to be there? S squared. So the formula is x is given by what? B t squared. So it's just a matter of making b as subject of formula. We divide both sides by t squared, even here t squared. So we're going to have what? We're going to have b is going to be equal to x divided by t squared. And then we plug in the values, right? So we have m divided by what? S squared. So what would be your conclusion in terms of this is the same as b is going to be equal to meters per second squared. So what would be your conclusion to what is b? Exactly. Any question there? Yeah, yes, we are going to do that. I want, before we do that, and then I'm asking to say, do we have some questions before we we proceed? Girls, Melody, let's interact, guys. No question. Okay. Um. So from there we know that um this is the same as we can write it in b is equal to m. Sorry. It's the same as we can write m and then s to the power negative 2, right? And then m is going to correspond to what? To length, right? Then second is going to correspond to time. So we're going to say our b is going to be equal to this, and then we put t to the power negative 2. So these are the dimensions of b. I think it's just okay there. Now girls are not saying anything. Just a minute. uh, these guys from Musa, they're having a class again. They are using the same link, so they are joining this class. Imagine. Okay, so we go to b. So b is saying the displacement is related to time as x is equal to. So we have got the formula, which is x. And you know what, guys, these formulas we are going to be doing them in second semester. This is the formula for displacement under simple harmonic motion. and you're going to see how we're going to derive them. Where a is constant, then t is time, f is frequency, find the dimension of a. Hint: a trigonometric function appearing in an equation must be dimensionless. So we're going to consider these two guys to be no n units. Let me use different color there. So we're going to consider these guys just the way they are, no units. So we're going to be dealing with this, and this. Okay, so we want to find the dimensions of what? Of a. It's just a matter of making a subject of formula, right? Is that okay? Guys, are you still here? I can be talking around here. So we want to find the dimensions of what? Of a. So what we are going to do, we are going to divide both sides by what? We're going to divide everywhere by sine 2 pi ft. Then even here, sine 2 pi ft. So this and that will go. We're going to have our a is going to be equal to x divided by sine then 2 pi ft. So what we're going to do, we know that x is displacement, so it's going to be in meters, and then frequency is going to be in what? Do you know the SI unit for frequency? Yeah, apart from hertz, the square root, the SI unit for frequency, since hertz is it's not a basic quantity, we are using it second to the power 1, which is per second. It's the same thing, so we're going to use per second. Okay, so we're going to use per second. Then the time, it is second. So in short, per second, do you know that it's the same as 1 over second? So maybe for us not to disturb anyone here, let's just say frequency, it is 1 over second, and then time, it is in second. Now let's plug in the values there. It's going to be a is going to be equal to, where there is x, let's put meters, and then divided by sine open brackets 2 pi. This is a trig function, so it's going to be dimensionless, as well as these guys, because they are constant. Okay, and then where there is frequency, we are going to put 1 over second times second for the time. Does that make sense? Don't you think that yes, don't you think we have this down there, we have got 1 over s times s? Don't you think that we can cancel s and s? Yes, we can. So if we can do that, then guys, we can say that our this guy and that guy will go. Then we are going to remain with a, or just allow me to do it from there. Then we are going to say a is going to be equal to meters, then we have sine open brackets 2 pi. Then now we know that mass corresponds to what? Length. That's all. We don't have anything else. Then what we are going to do, we are going to replace where there is mass with L. So we're going to say that our A is going to be equal to L, then divided by what? Sine 2 pi. Now we know that if this one is down there, it's the same as, we can write it as A is equal to A L, which is going to be times, then we can even say this, so that we put them in brackets. We say this, and then I put -1. It's the same thing. Have you gotten it? Yeah, it's the same thing, so don't worry about that. Any question there? Is everything okay? Yes. Questions? No questions. We move to the next question. Okay, cool. So I'm going to go there. Allow me to go back, and then we get this question. Okay. So, and then I do this. Okay, so we can start, right? Now the question is saying a shape is saying a shape. Just a minute. There's someone who is trying to join the class but is failing. Let me send the link. But are we following, guys? Okay, so the question is saying a shape that covers an area A and has a uniform height h has a volume of v is equal to ah, and then it is saying that show that v okay, just a minute, sorry. Okay, I'm back. Sorry. So we're saying that a shape that covers an area A has a uniform height h and has a volume of v is equal to, so we can write the formula there, which is v is equal to ah. Show that v is equal to ah. Show that v is equal to ah. Dimensional is correct. You remember what we were doing yesterday? Okay, cool. So what are the SI unit for volume? It's meter cubic, right? Then area, meter squared. Then height, meters, eh? So what we are going to do is we are going to put there m. We know that the units there is going to be m to the power 3. Area is m squared times m. And then we are going to say that m is the same as it corresponds to length. So we're going to put length there. To the power 3 has to be equal to have l to the power 2 times l to the power 1. So this time this one we're going to get to the power 3, right? So we're going to have this. So as you can see, the left hand side is the same as the right hand side, which is same. Questions? No questions. Everything is just okay. Everything is just okay. Okay, cool. Question B is saying show that the volume of the cylinder and a rectangular box can be written in form of V is equal to AH, identifying A in each. What are we supposed to do here? Show that the volume of the cylinder of a rectangular box can be written in the form of V is equal to. Do you know how the rectangular is? They are saying identifying A in each case. It's a discussion. I want someone to contribute there. What are we saying? According to you, they're asking about the dimension of A. Okay, what of others? What are they asking us? Hmm? Guys, you are too quiet. You are too quiet. What's wrong? Hmm? You are too quiet. What's wrong? I'm asking. Hmm? Okay, go ahead. I don't know. Let me check your name. The one who is from contributing. What's your name, sir? Your name is difficult to pronounce now. Chapel. You don't have nickname. That name is difficult now. Samist. Okay, Samist. Go ahead. What are we supposed to do? So now to find the dimensions of A, what I was supposed to say, we start by making A as a bit of formula, and then after that, what I'm going to say. Okay. Okay. Now the question is asking us to say we need to show that the volume of the cylinder and the rectangular box can be written as, okay, it's more like we have this, guys. They're asking about two questions. We need to show we have got, you know what a cylinder is? What is a cylinder? Okay, okay, okay. Yeah, yeah. Okay, so this is a cylinder. Aika. So this is a cylinder. Let's say that is our cylinder. So we know that a cylinder is going to have height, which is going to be h, as well as that the radius, which we are going to call it r. Does that make sense? And then we know to say the volume of cylinder is given by which formula? Is going to be what? Area times height. But do you know that you can say, you know this formula? Do you know that A is constant in that case? Where we are going to say that maybe we know that the formula for calculating the volume of the cylinder is given by is pi r squared h. You get it? Huh? So A in this case, the formula which we have this formula. A in this case is what? Pi r squared. Have you seen? Hmm. So now I want you to think in that angle. That's the reason why we have been given that V is given by A over H, where A we are going to consider in this case for a cylinder is going to be this one. Okay? So that you know to say this one is going to give us is R is squared. So it's definitely this meters squared. You get it? Now let's go to rectangular block. Do you know the shape, the way the shape of rectangular block is, the way it looks? So let's say I'm saying that our A is going to be this. So the rectangular block, the way it is, guys, is more like you have. How can I draw it? You have this, and then you have this. So we're going to have length, breadth, height. So how do we calculate the volume? Uh, or before we do that, how do we calculate the area of the rectangular? L times B. So now, if we can say L times B, don't you think that this A is the same as the A which we have in the volume of the cylinder, because it's going to give us also, it's going to give us the unit which is going to be what? M squared. But also this one gave us what? M squared. Have you seen? Okay, cool. So if you have seen that way, now the question is saying that show that the volume of the cylinder and the, it's the same thing to say this A is constant, meaning that the volume of the rectangular is L times B times what? Times H, right? So what is A times B? It is the area which we have A. So we're going to say V is going to be equal to, you put A there, times H. At the same time, this A in this formula, it is A is given by pi r squared. So we're going to replace this one with the A which we have. That's why the formula is the same. A, then H. So this is how you can show. You are supposed to draw this for to my rectangle. So this, as you can see, the formula for this guy and this one is giving us the same thing. This is what they want us to show. That's why they are saying show that the volume of the cylinder and the rectangular box can be written in the form of V is equal to A. So how can we show that the rectangular block as well as what the cylinder, it can be written as V is equal to A H. So this is how you show. Now they are saying identifying A in each case. So we have identified that A in this case for rectangular block A is L times B. This is our A. Then this one for cylinder, we have to identify that A is pi r squared. So we have identified. Have you seen Mr. I've forgotten your name again. Have you seen Mr. Samis? Okay, cool. So that's how we solve that question. So as you can see, the figures, they correspond to each other. So meaning we have showed that the formula is the same, both rectangular as well as what? As well as the what? The cylinder, yes. Okay, next question. Any question before we move? Maybe we have some people who have questions. Only two people here participating. The rest. Go ahead. We didn't consider the aspect of what do you, what oh, you are thinking the sign should not be part of our answer. Okay, what it means when they say dimensionless, basically it's the same thing even if you include it. They're just telling you to say it has got no units. You get my point, right? It's either you can eliminate it, it's okay, or you can include it, but it has got no units. Yes, you get it. So you don't have to temper with it. It's more like a constant. Uh, for dimension sake, yes, it can make sense. But even if you consider sign, they can also mark. But for dimension's sake, you can just light the L is just okay as well. Sure. Any question, guys? No question. Everything is clear. We go to question 3. Now, this question, they were asking about what? They, I don't know, but I think they were trying to ask to say we're supposed to to see to prove. I think I don't know, but the question is not. It's incomplete actually. It doesn't make sense. How can you just at each of the following equation was given by a student during an examination? So we do what with it? So we make our own question. Yeah, that was the question, I think. So we start with, you remember the principle which I told you yesterday about the dimension? We say that what? For you to prove, for example, we have that one which is half mv squared is equal to half mv initial squared. Then you have this. If you can remember what I said yesterday, I said when we're dealing with dimension analysis, what do we do? Then apart from that one, what else? What else I was supposed to do? Exactly. Yeah. So if you want to prove that this is the same as, you can just get this part only, or you can get this part only. So which part do you want us to get? Okay. The one with the square root. Okay, so we have this. We have half mv squared. We have to prove that this has to be equal to mgh. Okay. So we know that this one is going to give us what? It is the mass, so it's going to be what? Mass, kilograms, times velocity, meters per second. Just allow me to do this. It's the same as if I do this, eh? No, 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 no. It's supposed to be like this. And then, why? What if I just say, maybe I can confuse you. Okay. For the sake of not confusing anyone, let's do this. That v is squared, right? So we're supposed to square it. Have you seen? Then do you know? You remember yesterday we said that this is the same as if we can say mass g h is the same as, okay. Do you know that this is the same as, it's the same as m g h? Then I put in the brackets, I put to the power half. We agreed yesterday, remember? So then we know that if that is the case, we know that mass is going to be kg, the mass, and then g, this is the acceleration due to gravity, which is what? Meters per second squared, right? Hmm? Meters per second squared. And then we have what? H, which is just meters, right? And then we put them in brackets to the power half. You remember? This is what we said yesterday. Yes. And then now from here we are going to say that I want us first to do, before we even apply the, we know that this one is going to give us the same as kg times m to the power 2 divided by s to the power 2 has to be equal to, this is going to give us, this one is going to give us the same as kg, and then we put, is it, I put half, and then I have, again this one is the same as if I say m to the power half divided by, so here if I do 2, it's more like I have this, then I have got 2 already, then outside there is half. Don't you think they are going to cancel out? Okay, so if they cancel out, then we are going to remain with s on, right? Times m to the power half. Cool, right? Okay, and then from there what are we going to say? We are going to say that this kg, okay, allow me to write this. This is the same as kg times m to the power 2 times s to the power negative 2 has to be equal to kg. Do you know that this is the same as kg to the power negative 2? You're behind there. You are behind there. Okay, there is half, and then what else do we have? What else do we have? Then we have this one is going to be m to the power half. Then again you have s to the power negative 1. I think you're not confused there. Okay, you're not confused up to this point. But we need to understand. Yes, we need to understand again that. Okay, I will show you when we do everything. Now, what is remaining now? Do you know that this m, we have got m to the power half times m to the power half. If the bases are the same, what do we do with the powers? So meaning, what is half plus half? It's going to be m to the power what? To the power 1. So this one is going to come like this. It's going to be now kgs, and then m to the power 2 s to the power negative 2 has to be equal to kg to the power half times, we have what, m is going to be just m, and then s is going to be s to the power 1. What else are we supposed to do? We add the dimensions for kg. What is the dimension for kg? Okay, so if we are to add that one, what are we going to have? So this one is going to give us length, right? Sorry, mass. And then this one is going to give us what? Length. But it's going to be squared. Then this one is going to be what? Time to the power 2. This one is going to give us what? Half, and then times what? The mass is what? Oh, length, then time to the power negative 1. But why is it giving us different things? It's not giving us the same. What do you think it can be the reason? Exactly. Yeah, the equation dimension wrong. So this one is supposed to give us the same as if we get this, it's supposed to give us the same as this. So this is total dimension what? Wrong. You have seen, right? Cool. We go to the second one. But these ones I think you can do, guys. Can't you do B and C? So we move to the next question. Now the other guys are just quiet. Yes, yes. Yes. Exactly. Same. But now see, what we are trying to say is that okay, let me give you an example of this. Have you seen B part B where it's saying V is equal to V initial plus AT squared, right? When you get this part and this part should be giving you the same, as well as if you get also this part and that one, you are supposed to get the same thing. But if only you can prove to only one part, only this and this one, and not this one, meaning it is dimensional wrong. But you are supposed to, even if you use any, you are supposed to get the correct thing. You get my point, right? You choose. You ch- no, no. You can't conclude from there. You are supposed to check both sides. Exactly. Yes, yes, both sides. You get this one because I need to say the reason why we didn't do this one was we know to say this is the same thing. But okay, let's do this one. Let's check the part B. It's the same thing, right? Okay, I want just to show you. Yes, you yeah, you just check both sides, the first one and the second one, so that you see if you are getting the same thing. If you're getting another thing the same, but the other thing is not the same, then it's dimensional wrong. So as you can see, this one we are going to get the same thing, right? These two. But now when it comes for AT squared, you know that A its acceleration is going to be meters per what second squared. Then T squared, even this one is going to be wrong because you are going to cancel these. So it's going to be wrong. Okay, I think you have gotten the logic there, guys. Okay, cool. We go to which one now? But time is not with us. Just choose. We are remaining with because we started at what time? So we're supposed to end at what? 21:20, right? So we can go to question 4. Anyway, let's go to question 4. Okay, cool. Okay, let's do everything, guys. I don't want no, sir. You didn't do that. Let's do everything. We are going to do question 4 as well. Then question 5, then 6. What is question 6? Okay, question 6. These are simple. Then question 7. I want you to try question 7 as an assignment. Then when you fail, I'm going to teach. But I know you can't fail. Okay, so the question is saying kinetic energy has dimension kg meter squared s to the power 2 negative 2. Then it can be written in terms of momentum, which is p, and mass m as in. So they are saying that is the formula for kinetic energy, which is p squared divided by 2m. They're saying determine the proper units for momentum using the dimension analysis. So what are we supposed to do? subject of formula. Okay, cool. So we're going to do times, right? So it's going to be what? It's going to be p squared, right? Is equal to what? Kinetic energy times 2m, which is the same as, for us not to be confused, the same as 2 kinetic energy times m. So m, we have been told that is mass, then kinetic energy is measured in what? But since this one is squared, why don't you think that we can just square them so that we make p as a bit of formula? It's the same thing, right? So let's square it. So if we are to square it, guys, then it's going to be p is going to be equal to the square root of what? 2 ke times m. Then at the same time, we know that this again, it is the same as, anyway, before we do that, we are going to do, when we are done, we know that this guy, it is the same as 2 ke times m to the power half. It's the same, right? Cool. And then we also know that if this is the same, then we can say that what are the units for um, kinetic energy? It's joules, right? But this joules, we know that joules is the same as what? Okay, for the sake of kinetic energy is given by, it's the same to say kinetic energy is given by half mass v squared. So what are the units? In fact, we have been given already, right? They are saying that the kinetic energy has dimension. We have been given kinetic energy as kg meters squared s negative 2. So there's no need of us panicking. So these are the units. So what we're going to do now, we are going to put there. Can I just remove this part? We have, so we have 2. Then kinetic energy we are going to replace with what? Kg meter s to the power 2. And then meter again we are going to put what? This one. No, it's mass, right? It's going to be kg as well, right? Hey, you have stopped responding now. Okay, so and then we are going to say I can just get rid of this. So that is what we have. So we know that kg, but before we even do that, we know that this guy and this guy is going to give us kg squared, right? But we have forgotten one thing, half to the power half there. P is going to give us what? It's going to give us 2 kg. I've done kg times kg is going to give us kg squared, m squared, s to the power 2. Then we do everything to the power negative. Oh, sorry. To the power half. At the same time, if I do that, guys, don't you think that if I'm to get this guy to come here, it's going to give us p is going to give us 2 to the power half, and then times kg 2 times half times m 2 to the power half times s negative 2 to the power half. We are okay there? Okay. And then we can say that p is going to be equal to, this is the same as what? 2 to the power 1 over 2 is the same as what? Or 2 to the power half. So what is root of 2? Okay, anyway, we are trying to find the units of the unit. So it doesn't, even if we just leave it the way it is, you can put it in square root if you want, but it doesn't necessarily because we're trying just to find that is just a constant times what is, don't you think that this they will cancel? We're going to remain with only G. Hmm? Yes, it's a constant, yeah. Exactly. So we can just remove. Yeah, yeah, exactly. Because we are trying to get the units, so it's okay. We can just remove. Or if you want, you can leave it the way it is too. Then when reporting now, okay, let's do this. It's just like that. Then you are going to say that this one is going. Don't you think that this and this they'll cancel? They'll cancel, right? We're going to have that, and then this and this they'll cancel. Then we're going to remain with -1. So now when putting from here, we're going to leave this -2 because it is a constant. So we don't deal with constant, we want just the units. You get right? That's what we said yesterday under the rules. So we're going to say that we are going to have kg m to the power s this. Then we know that kg is corresponding to what? To mass, but capital mass. And then meters is corresponding to what? Length. Then s, which is seconds, corresponding to time. Then we are going to put there. Momentum is going to give us m. Then the mass, oh sorry, the meters, which is going to be the length. Then we have also the time, -1. And for sure, guys, if you know momentum, what is the formula for momentum? It's mass times velocity. So velocity is mass per second, which is this part. So this is correct. Then this is the mass which we're talking about. You get right? You get yes. So what of part B? It's saying that given the units of force as kg meter squared, what, okay, that is force. Write a simple equation relating to the constant force F exerting on an object, an interval of time during which the force is applied, and the resultant or resulting momentum of the object P. What are we going to do according to the rules which we said yesterday? So we're going to say force is going to be direct proportion to what? Momentum and time. Then we said we are going to replace this guy with what? Which is going to be Ki. So here they want what? Simple. It's an equation. This is what we are doing yesterday. So we are going to say that this we are going to replace it with K, equal to K. So we are going to say that force is going to be equal to first, just a minute. Given that the units of the force is or we have been given the units, light and simple expression, okay, of force, what, okay. So we said it's going to be kpt. Remember, we said we really don't know the power of t as well as the power of p. You remember what we said yesterday? Those who can remember. So what are we going to do here if you can remember? Exactly. So we're going to say we're going to get the power. This one we have been given already. That is this guy. Let me use lead. This one. So we're going to put the force that is what is kg. Then you have m s to a power 2. It's going to be equal to, we have what, k is constant. This is the original formula, but we want just to find the powers. So we're going to say p is going to be raised to the power x, t is going to be raised to the power y. So we know that p is momentum, but we have found already the momentum, right? We know the units for momentum. We say that is what? Those who can remember. Kg meters. Then what? Second, right? To the power -1, right? So we are going to say that kg m s to the power negative 2 is going to give us k, then p to the power, that momentum we are going to put it there, which is going to be what? It's going to give us open brackets, then we are going to say k, then this is going to be what? Everything raised to the power x, then here t is going to be what? T to the power, which is second to the power y. Then from here, what do we do? What do we do from here? Okay. Okay, cool. So this one is the same as we can. Is it the same? Okay, it's the same thing. We say kg m to the power a or s to the power 2 is negative, right? I've forgotten negative there. Then we have got equal to, we have k, then it's going to be times kg to the power x times m to the power x, then times what? S to the power negative x, right? Times s to the power y. I can now get rid of this. So we know to say, now from here I'm going just to put the dimensions. I know that kg is what? Is m, right? Then meters is L. Then this one is going to give us what? T to the power negative 2 has to be equal to K. This one is going to give us what? Mass to the power X. This one is going to give us length to the power X. This one is going to give us T to the power negative X times again T to the power Y. So do we have things in common here? Okay, first let's do this. We have things in common, so we can just write m, and then we have L, and then we have T negative 2. So we have things in common, which is L, T and T, right? And then we have T and T, right? But why do we have T and T, and then we have how many X? It's the same thing. We can just find. Okay, cool. Let's get this. We have M, and then we have another one, which is what? L, X, and then we have this one is going to give us what? Negative T minus 1, right? Yes, these powers. It's going to give me negative X plus Y, right? Here there is X. Okay, let's now go ahead and find the answers. So we know that we are going to equate this equal to what we have there. So it's going to be, what is the power there? Is power 1. This one is power 1. So we're going to have x is going to be equal to 1 for m and m. What of L and L? It's the same. I want to show you to say it's the same thing, right? Even if you get this one or that one, you're going to get the same values of x, right? Hmm? What is the value of y? So we have the second one, which is negative x plus y is equal to negative 2. So now we know the value of y, that is negative 1 plus y is equal to negative 2. So y is going to be equal to negative 2 plus 1, right? So what is our y? Hmm? Negative 1. Now, after finding that, then we go back to our formula, which is this. Our formula is force is going to be equal to K P T, but this was X, this was Y. So let's just plug in the values of, so it's going to be like this. K, what is X? X is 1. What is T? Or Y, sorry, it's negative 1. Don't you think that when something is negative 1, it's the same as force is going to be equal to K, then P divided by T? So this is the formula which they wanted us to get. I don't know if you have gotten the point, because we did these things yesterday, right? Cool. Any question? No question. Everything is clear? Yes. We go to next question. You should be checking there. I want you to be checking here. Are you able to see this? The arrow is 55, 56, meaning we are meaning 6 minutes. So meaning we started at 30, because that recording is showing there. Okay. Next question. We go to see. We are done. Should we do this one? Oh, we do 5, eh? Let's do 5. Then are we going to do 6? Our next lesson I wanted us to do vectors. Where are you in physics first with your lecturers? You are done. You're done with dimensional analysis already. Eh? You are saying you are done. You are saying you are done. The one who is telling me, the one who was responding. Again. Okay. So that is the question. And then the question is saying the radius of the circle is measured. We have that radius. Calculate the area. So uncertainty. I didn't mention about this anyway. It's simple thing. There is nothing. We have 10.5 plus or minus. Do you know what when it this is an error? You get right? This part is an error. You can make an error which is going to be 0.2. It can either be plus or minus. It can either be plus or minus. It's more like when the original answer is 10. For example, when they're marking your papers, right? If the answer is 10.5, or let's say the answer is 10, right? And then someone writes 10.02 meters, and someone writes 10 meters. It's the same. They can give you a mark, right? So this was just an error. So that is what it means. You get my point, right? So it means that that is an error. This it is uncertainty error which you have there. And then when calculating, you are supposed to include it. So for example, what is the formula for area or the circle given the radius? So area is given by pi r squared. So now what we are going to do, since we have got an error, we are going to say this. area is going to be given if you have been given the what, the error. So you're going to say it's going to be pi, then you put capital R squared, then you put plus or minus, then again small pi, then comma small r squared. So this part is for the error. That is where we are going to be using, we are going to be putting this. If you don't have calculator, you are supposed to buy a calculator. I don't know where I've put my calculator. Do you have someone who has got a calculator? So what you're going to do there, guys, is going to be area is going to be equal to this plus or minus, and then we're going to have small pi, then what, r squared. Then let's now start putting in the values. Have you gotten the point there? So what is our radius? 10.5. So we square it, plus or minus pi, then that one is 0.2. We square it. Those having calculators, give me the answer for the first part before plus or minus. You don't have calculators? Okay, you punch and give you for the, since you don't have calculators, you can just punch and then you are going to give me the answers, right? Yeah, so give me the answer if you do have. Okay, I found my, oh no, it's not a calculator. Mm-hmm. Times pi. Me, I'm getting these answers from you because I don't have calculator. So don't blame me, right? Meaning we are going to blame this guy now. Come again. 346.5 plus or minus, what was that other part? Hmm? 0.125. 0.125. This one? Since this one, okay, just a minute. Since this one, you need to be very much careful, especially for chemists, although physics they don't pay attention. This one, it is in how many significant figures? The one I'm pointing in red? One, right? So even your final answer is supposed to be in one significant figures. So you can just say 1.0 or 0.1. You get, you are getting my point there, right? So, but first you can write the way it is there, no problem. You can put there, then you put meters. Then now the final one you'd say 346.5 plus or minus 0.1 then meters. So since it is area, then it's going to be what? Meters what? Squared. So this is the answer. Part B. Part B is not difficult. It's just a matter of you knowing to say, they're asking to say a car is traveling at a speed of 38 meters per second on an interstate highway where the speed limit is 775 miles per hour. Is the driver exceeding the speed limit? This is just you need just to know the conversions. How many? Oh, sorry. Yeah, the circumference of the circle. What is the formula for circumference? I didn't see part B. 2 pi r. So it's the same thing. You're going to say circumference is going to be 2 pi the square, or the capital R, plus or minus then 2 this r, then put there. Then the answer which you're going to put is going to be in what? Meters. There's no need of us putting the digits there. You know what we are supposed to do, right? Now I want to ask you, the part B, or part C, sorry, is saying a car traveling at a speed of 38.8.0 meters per second on an interval highway where the speed limit is 75 what, that is 75.0 miles per hour. They want just you to convert this one into meters per second. Then if it's going to exceed for 38, then the car was exceeding the speed limit. Have you seen? So do you know how to convert from miles to meters per second? um okay, let's use dimension analysis to convert that one. Let's see. So it's going to be 75 mile per hour times, in 1 mile, how many meters do we have? Hmm? It's 1000. It's not 1000. It is 1609.34 meters. But this they'll give you if they. But anyway, you need just to know them. For example, this one is 1600 and what? 9.344. That is, in 1 mile there is 1609.344 meters. You get it? Huh? Then now, meaning we have converted that one. Now we are trying to convert now what of in 1 hour. How many seconds do we have? We have 3600. We know these things, guys. So the hour and hour will go, the mile and more will go. So those having calculators, can you do fast? Time, guys, time. I want to do question 6. Hmm. Are you sure? You guys, what kind of calculators do you use? Let me also try using the phone. Where? Okay, so what is your conclusion? Is the driver exceeding the limit or not? Justify your answer. Exactly. Exactly. So 33, you are saying is 33 point what? 33.5 is less than what? 38 point. So it was not exceeding the limit. It was just in a normal way. Hmm? Okay. Oh, okay, yeah. The speed limit is 75. Oh, I thought maybe the question was saying that the speed limit is this one. Okay. The speed limit is 75. Now, the guy is traveling at 38. So, the speed limit is 33.5. Okay, yeah, thank you. So, what is the conclusion now? Justify your answer. No, you guys, no. The speed limit is 33.5. Then someone is traveling at 38.0. He's not exceeding the limit. He's exceeding. You get it? Huh? Uh-huh. Exactly. Uh-huh. Uh-huh. You have not gotten the logic. See, it's more like um it's like this. The speed limit, you are supposed to be traveling at 33.5 meters per second. This is the speed limit. You get my point, right? Once you exceed this, meaning that you are exceeding the limit. So you are traveling at 38.0 meters per second. Are you not exceeding the limit? You have seen it? No, we were converting 75. We are converting the 75 miles per hour. The yes, it is the speed limit. You get it? Huh? We are converting 75. That's what we have done here, and we have found that it's 3.5. Cool, perfect. We go to last question. Question 6, right? So can we spend 6 minutes here to solve this question? Two. Okay, they are saying that treat the cell in a human what? As a sphere of radius 1 micrometer. Did we talk about micrometer yesterday? So 1 meter is equal to 10 to the power 6 micrometer. So if I want to convert that one to meters, it's going to be 1.0 times 10 to the power what? Negative 6 meters. Using dimension, do you want us to use the dimension analysis? Using dimension analysis is going to be 1.0 micrometers times in 1 meter. How many micrometer do we have? We have 10 to the power we have 10 to the power 6 micrometer. So this and that will go. So we're going to have 10 1.0 times. This is the same as this one. It's the same as we put 10 to the power negative 6. I've just shifted there. I've just removed this part. Yes, meaning it has come now meters. So this is what we're going to be using 1.0 times 10 to the power negative 6 meters. Now they're saying determine the volume of the cell. So what is the volume if you know the sphere? The volume of the sphere or the volume of the sphere, how do we calculate it? But basically if they give you these questions in test, they give the formulas. Is 4 over what? So the volume is 4 over 3 pi r to the power 3, right? That is the volume of the sphere. So we have the radius. Yes. The units for volume, it is meters or cubic meter. Yes, sure. No, like if you use, these are not the units for volume. That's the reason why we did measurement and units. for you to know how to convert the units. So it's always to put the SI units. So it's going to be V is going to be equal to 4 3 pi times the radius is 10 times this. Now everything to the power to the power 3. Find the answer. First, those having calculators, fast guys. So that is the volume of the cell which you are going to find. Let's find first. Mm-hmm. Okay, times 10 to the power what? Negative what? Mm, guys, have you squared this to the power 3? This time, this one is going to give you, it's supposed to be to the power negative 18. Although I've not calculated, but you are supposed to get negative 18 because this time, this one is negative 18. That's what you're getting, right? Do fast. No. No. You can't get 2.9 because pi. No, bro. Pi around is 3.14 somewhere there. Then it's more like these they are going to cancel. 3 and 3 they are going to cancel. And then you're going to have 4 times this. You're going to have almost about 4 times 1 point, I think 1 4 somewhere there, which is supposed to be 4 point something, not 2. Now guys, you are making me now to start looking for calculator now. 4.19, right? No. It You guys, what are you doing first? No, it can't be 1. Listen guys. Yes, it's 4.99. See, even if I don't have a calculator, I need to know that this guy here time this one I'm going to get negative. That's why I've put negative 18. The power is supposed to be negative 18. Then what you need to know that pi is somewhere there about 3.14. I don't know if that is pi. So you have got 4 over 3 times 3.14. Don't you think that this one in there you can cancel this, and then you're going to have 1 there. Then 3 into 14, it goes how many times? 12 is 4, then point somewhere. So if you do this time this one, you're going to get 4 point somewhere. 4 point what? You get it? Huh? You don't know how to punch. Okay, listen. Do you know how to punch pi? No, that's the reason. Nah. Pi is already there, my brother. Check down there. You just punch where there's shift, then press where there's pi. Have you seen pi down there? Yes, shift or press where there's shift, then press where there's pi. Then times open brackets, or just do open brackets. You have done that. Then 4 divided by 3 cross brackets. What are you getting? Okay, which is the same as to the we round it off is going to be 4.19, right? Okay, so then we can move to part B. Estimate the volume of your body. Okay, so how can we estimate the volume of the body? Okay, um, a body is more like we have this. It's the same thing. You remember when we had this, that formula which they gave us? Remember that question? Mhm. So now what we're going to do is this area, which is the same as area, right? The volume, in fact, when you want to calculate the volume of the body, it's given by the formula V is given by pi r, then you square it times L. Why are we getting L? We are getting the height. I've given L. Anyway, we can say height. Okay? Your height, in short. It's the same as length. You can put H if you want. So we estimate the volume of who? Me or anyone from here. So we estimate that your radius is what? We can put N. It's just to estimate. You use N. Even the length, we're going to use N because we're just estimating of your body. Let's estimate to say the radius is 0.2 meters, and then let's say that what can be the length? 1.6 meters. Let's put that. Now do it fast because of time. Then we have estimated this 0.2 squared, and then times 1.6. What is the answer? 0.201 meters cubic. So that is the volume of your body. The volume of the body is going to be given by 0.201. No one is going to penalize you because we are estimating. Now, part D. See, estimate the number of cells in your body. It's more like this, guys. If this is the body, the volume, this is the volume of the body. Then we have got the cells. These are the cells. So we know the volume already of the body, that is this one. Have you seen, right? Now we also have the number of cells. We have the volume of the cells, each volume of the cell, the volume of each cell in the body. So now to estimate the number of cells, what do you think we are supposed to do? We have the volume. This is the volume of the whole body. Then inside we have got the cells. Now each cell has got this volume. Exactly. So you say that the number of the cells is going to be the volume of the body divided by what? The volume of the cell. Then you are going to get the number of the cells. So you just get 0.201 divided by what? 4.19 times 10 to the power negative 18. So that will be the number of cells in your body. Those who are calculating, what are you getting? 4.77 times 10 to the power negative 20 cells. That's all. What else do you want, guys?